We're all about breaking down remote video protocols, ways of moving video from point A to B, and we put together, I think, a really, top shelf group of presenters today. We're going to have 3 presentations. The first will be from Tom Pierce, again, a friend and colleague of mine from Maine. He lives in the Portland, Freeport area, actually, home of LL. And Tom is somebody who's been doing this for a long, long time. I've worked with Tom as a broadcast engineer. We've actually traveled around the world. At one point, we found ourselves in a pretty interesting situation with NOAA. They have a ship that goes out and dives and explores the oceans, and it has a big HD camera mounted on it, and you have to have a video engineer operating that camera. So he and I ended up on a adventure out in Indonesia for a couple of months, one summer. It was really fascinating. But Tom is somebody who really does this on a daily basis, and I'm going to let him talk a little more about that. But it's interesting, we are all, in some respects, in our own little worlds. I ran an access channel in a community college like this for many years, and I know how, when it comes to technology and things moving so quickly, it's difficult to stay on top of it sometimes. I always enjoyed my interactions with people like Tom, who's a professional broadcast engineer. He works mostly on big mobile television trucks, doing broadcast television remotes around the country. And again, he can talk more about this. But having done some of that work myself, I know when you go out into the field and you're working in a big commercial environment where they have budgets to find solutions, and you have the ability to solve these kinds of technical problems that we're all dealing with all the time, that's one thing. And it's not always easy to know, are you going to use a satellite truck for this, and what are we going to have for redundancy, and how are we going to make sure that this signal gets from A to Z, and what's the backup? And this kind of stuff in the broadcast world, it has to be done to a certain standard. You've got a lot of money on the table, and people really expect that the engineers who are working these remotes are going to solve whatever problems they're given. And I know that on the local level, in an access environment, we're dealing with the same things. We're trying to get video pictures from different places, put them onto our channels, push them up to the internet, do live streaming. And boy, hasn't it changed a lot in the last few years. So again, I thought it would really be interesting to have a workshop, a forum like this, where we brought in some experts and just took the morning to explore this topic. So Tom's going to start the first hour and give us an overview of different protocols, things that he's using out in the field, and get the conversation going.
Morning, everybody. Thanks for coming out. Tell you a little bit about how I get into this messy business of video streaming. I'll give you my elevator pitch. I'm a broadcast engineer from Maine. I go to places, I fly to a different city every week. I go to a place that has no television equipment, and I carry everything that you have in your studio in a truck. We take it all out. It's about $10 million worth. We set it up, we test it, we shoot the show, we tear it down, we put it back in the truck. I'm responsible that all $10 million of stuff comes back. So inventory is a big part of my job at the end of the night. And then we go on to the next city and set it up all over again. It's just like working for the circus. So this is my mobile office. I'm in it most weekends, and every time I open the door, I see a new place. It has its ups and downs, just like any other job. So that's what it looks like inside. So, so it houses everything that's in your studio, except that I've got to manage power and air conditioning to make sure the gear doesn't fry, and tell everybody to wear a coat because the air conditioning isn't for them, it's for the equipment. And it houses about 20 people when we're really, really busy. So we have an audio department, we have a production area that has director, producer, technical director, we have instant replay, We have video engineering. I'll show you a couple of pictures. So one of the jobs that I did during the presidential campaign was my truck served as the remote control room for the Today Show for an interview with Matt Lauer and President Trump in New Hampshire on the campaign trail. So we get used for lots of different things. Let me show you another picture I wanted you to see. So the truck is set up to hold, unlike a regular trailer that you see running down the road, it's got lots of nooks and crannies for sticking stuff. And we have compartments underneath called belly bays, and they have the power and the cable, and that's where the cameras live. Our control room has, so we use pretty inexpensive computer monitors for general monitoring. And they'll have a device on them that has a quad split, so you can get 4 monitors out or more out of one. And then the 2 monitors that you see in the middle, those are the really high quality. So you have two monitors for quality control, a preview, and just like you do when you control them. The expensive gear, the expensive item is the grand piano in the corner. That's called a Cayenne Grass Valley switcher. It costs about $500,000, and that has. It has 4 and a half mix effects banks, and it also has its own video playback and recording so when you're watching the game and the graphic goes by and it shows you a replay, this guy's got that at his fingertips. Playback device that's just for special effects. So I get to work and a truck full of gear gets dropped at my feet that I've never seen before, with an operator standing next to it saying, "Can we get this working? I need to start typing stuff in." And that's what I work with each day. So gear I've never seen, figure out how it works, figure out how to integrate it into the system that I know works, and do it within about, if I'm lucky, I might have 6 hours before they really start wanting to do production, usually sooner. If it's a big show, we might have a day before. And as Randy mentioned to you, we've done some interesting stuff together in terms of broadcasting. One of the pleasures that I've had is doing this kind of work, remote television work on a ship. Randy and I have worked on a ship from NOAA that's just like this one. This one's called the Nautilus, and it's owned by a gentleman that you may have heard of before. His name's Bob Ballard, and he discovered the Titanic, and his office isn't far from here over in Narragansett. So there's a master control center over there for the communications between the ships, and it's called the Inner Space Center. I don't have a picture of it right now, but Randy and I have both worked on ships like this. When we're not working in the control room, that's me on the right, we are deckhands and helping get the equipment on and off the truck, on and off the boat. So the interesting thing about doing this work is they use the same equipment that we do in our control rooms. And the control room for the ship was actually built by the same company that built the TV truck that I work on. So communications gears, the television gear, the transmission gear between so this is using a robotic submarine that can go down 5,000 meters. So the Titanic's at 12,000 feet. So around 16,000 feet, hanging off a ship. And I'm the ears. I'm the eyes for the pilot. So I don't do anything with the cameras until the pilot asks me to do something, because he's depending on me for driving the submarine. So that's been a lot of fun. It's a job that I do in the summertime, usually a few weeks a year, and you get to see things that you never had a chance to see before. But they use all the same gear that we use. So anyways, let's talk a little bit about streaming. So I'll just mention one quick thing on working on the ship. The transmission on this machine is what's called a gimbaled satellite dish, And so what it does, it's working really hard to keep that dish pointed at the satellite no matter what the boat is doing. And I don't have a copy of the video, but a National Geographic crew came on board to work with us, and they put a GoPro on the satellite dish to see what kind of shot that they would get. And it was, the interesting thing about it was that the land didn't move, but everything else did. So that the camera and the land and the satellite dish stayed in the same position, and everything kind of moved around. It just shows you how much work that dish has to do to stay attached to the satellite. So we're the cool thing about this particular job is that you can watch them work on the web at nautiluslive.org, and underwater you don't really have any sound to listen to because the machinery makes a lot of noise. So we just put the communications channel on what people are talking about. And so you can hear them talk, you can send in questions, you can say, hey, what are you guys looking at today, or that kind of thing. So it's a really cool aspect of our communications job. So to get back to streaming. So an interesting thing that's happened to me recently is I've seen a lot more streaming equipment in the broadcast world. And a device, LiveU, I think is what I used recently, LiveU. This little device right here. So this device is similar, it's similar to other devices. It allows you to take video from a camera or switcher, and it turns it into the right kind of material that can be moved from one location to the other using the internet. And I actually have done a few shows recently that used devices like this and others that was our only way of getting our information back to wherever it was going to end up. So I did a boxing match this past weekend, and we were on Facebook. We did the regular production and setup just like if it was going to be for a regular television network. So the content looked identical. It had commercials and billboards and content that they had created beforehand, and then the actual fight. And then so this kind of equipment has become a lot more mainstream in the last 5 or 6 years. Whereas the equipment to do this before was cost prohibitive, and the requirements of a bandwidth of how big the internet pipe that you needed to do this was, you had to get a dedicated line that was very expensive. So doing it was possible, it was just expensive and hard to set up, and now it's become a lot easier, and that's why we're talking about it today. And Comrex has got a similar box that they're going to talk about next. So some things to think about if and when you're thinking about streaming. So when Randy and I were kind of talking this over about what we would talk about, we decided, well, why don't we come up with a scenario that might fit in all of your bailiwicks. So for example, let's say that you've got an event that you'd like to cover in town, and that you've never done an event like this before. So let's say, so you're gonna, let's say in the town square, you want to have a camera that's going to cover a parade, let's say. So let's say we're going to have a camera here, and it's going to shoot across this area, and there's going to be a parade that's coming through. So what's the considerations of if we might use streaming video in this sort of situation? What are the things that I look at is when I'm presented with hey, how do we do this? Okay, what's the things that you got to look for. So if I want to do something like this in a remote location that I don't have any equipment in, the first thing that I'm always thinking about is power. How am I going to power my devices? So will I be able to get power in a nearby building? Could I bring a generator that wasn't too noisy, maybe have it offsite a little bit? Can I run on batteries? So that would be my first consideration. How am I going to run the equipment that I've got? So after that is, okay, what do I have to run? Well, I'm going to have to run the camera, obviously, and cameras can run on batteries, no problem. The next thing I'm going to have to do is I'm going to have to take the video that comes out of the camera and I'm going to have to put it in a device that's going to make it compatible with sending it on a network, on a computer network. So this isn't you know, computer network isn't specifically designed for carrying our video signal. We have, in our facilities, we have dedicated wires and we have dedicated equipment, and there's nothing else on that equipment except for the video that we're using. When we go onto the internet, it's a whole different story. There's all kinds of stuff happening. It's like going on to a 6-lane highway that is in standstill traffic. So, so we have to be worried about how is it that we're going to get into that 6 lanes of traffic, get our stuff that's happening live and get it to our facility or to a server that's going to deliver it to our users. How do we do that efficiently? And so besides power, we're going to need to figure out, so how we get our audio and video to the net. So that's going to take some sort of device, and Conrex has got one that they're going to show us today. So the device that that does that is called an encoder. An encoder. So it will take video, whatever flavor it is that we've got. Let's start simple. It's just going to be a single camera. Let's say it's an HDMI signal. So we go HDMI, which is could be a couple of different flavors on the HDMI. The two biggest things that I use are we'll take a step back and we'll talk about video formats. So HDMI is a cable and connection type. It's a transport. It's for moving the signal from one device to another. So for example, from your Blu-ray player to your TV, from your cable set-top box, from your camera to the device that we want to use to get onto the network, the encoder. So HDMI is a cable and connection or transport. We're going to be talking about transports more. Excuse my chicken scratch. Transport. On that transport is there could be different types of video. So two that I use a lot in terms of format is we talk about the video resolution. So resolution and frame rate. So the resolution is in terms of takes up individual pixels on the screen. How many do we have tall? How many have wide? Two formats that work on HDMI out of your camera. Could be 1080i or P. 1080i or P. So I would be interlaced. That means that it sends when it's drawing the picture from top to bottom, it may do every other line and then go back and draw in. So it takes 2 sweeps to make one picture. That potentially causes problems down the road if you use an interlaced signal. So computers prefer that you have a picture that's drawn all at one time, and that's called progressive. So when we're encoding this to use it in other things like sending it across the internet, editing it, putting in edit software, the interlaced signal can have problems with that encoding process. It will work. It can work. It take more effort. It can take more bandwidth to transport that particular stream. So progressive means you start you start at the upper left, and you don't finish drawing until you're done at the lower right, and then you go on to the next frame. Frame rate, so 1080 I or P can usually be 30 frames per second or 60 frames per second. And then the other format that I use a lot is 720p or progressive. So it doesn't have as many lines in the picture, but it's at 60 frames per second. And the sports networks like to use this one because when we go to play that back and slow it down, it gives you pretty clean slow motion replay. So networks like ESPN like to use 720p versus 1080i. Another note is that as you increase your frame rate and your number of pixels in the screen, it takes more bandwidth in order to send that. And right now we're not broadcasting over the air in 1080p. We're doing 1080i or 720p. So and that's because of the specifications of sending things over the air. If we go from 1080i to 1080p, it increases how much bandwidth that you need to move that data back and forth. But on the internet, we can do whatever format that that our computer will support. So we can get around the limitations of what we do in over-the-air broadcast. So we can do things like 4K on services like Netflix and Facebook and YouTube. We can do things that we can't do in broadcast because the limitations are only in how much we've squeezed the video into as small as possible. We're going to talk about how we do that next. That's called a codec. That's called a codec. Codec. All right, so we have to talk about so the frame rate and resolution, that's the format. So what's the dimensions of the picture? How many frames per second we're going to run? And to make all that work in the equipment that we have and the bandwidth that we have, if you think in terms of bandwidth as if you think of it in terms of plumbing and a pipe, a small pipe gives you a small stream, a big pipe gives you a larger stream. So we have, when we get our internet from a service provider, we pay for the size of that pipe as to how much we're going to be able to use for doing our web pages, doing our email, or sending video files. Video files are huge. They take up a lot of space. So we have to, in order to make them fit in the pipe that we can afford, or that we have provided to us by our service providers, we've got to take out redundant information from the video files in order to make them fit and to be able to send them over the internet, or over any network for that matter. So a codec is a process that takes information that's in the frame. So to give you an example, if we tried to send a file that didn't have any compression, it could be anywhere from 500 to a terabyte an hour, depending on the format of the video. Huge files, and we don't have the capability yet of sending that kind of video over such a small pipe. So we got to take out redundant information. So that's what the codec does. And there are several different types of codecs from different companies. I'll show you a couple of examples. So here's some descriptions that you've probably heard before. So sometimes there's some confusion between different terms. So codecs are a type of way to squeeze our audio and our video to make the file smaller but keep the quality high. A popular one for video streaming right now is H.264. And you may have heard other terms like MP4 that we'll talk about it in a minute. So there are ways of describing how this works. So codecs are how we make the files smaller. It's not the same as how we use to move them or what they're stored in. So another term that will come up is called a container as to how the video is held in what kind of a file. And the two are not the same. So a codec and a container are different types of files. So the codec is how we squeeze it. So it's squeezed on one end. It's sent to where it needs to go, whether it's just going over your local network to your editor, or whether it's going across the world to be received by somebody else on Facebook. So that's sort of the lowest common is how we're going to squeeze this file into a format that we can move to make it smaller. So, just one that's starting to be used now. I'm not sure if Comrex uses this or not, but a new one's called H.265. You may have read about it. Some people are starting to use it. It's sort of what's next, and it's another term for it is HEVC, or high efficiency video coding. And the reason I bring this up is that all of you are, at some point or another, are going to be shopping for equipment, shopping for software. You want to make sure that it's upgradable to whatever's going to be next, because as you know, with all of our equipment, you buy something today and then tomorrow, something better comes out and something that's not compatible with what you have. So the same sort of thing is true with this equipment, whether it be software or hardware. You want to ask, how are we going to handle what comes next? Is this upgradable? Can we go to the next container, the next transport, the next codec, whatever? I'm sure all of you had to deal with this, dealing with cameras and edit systems. Every time a new camera comes out, they've got a new way of storing their files. And if your edit software or edit hardware can't talk to it, then you can't edit what you just shot. So it's the same conversation, same types of things happen. So besides codecs, we also have what are called containers. And these aren't always compatible. So here's just a sample of a few. There's lots of these. Some of them that you may have seen before. FLV for flash. MP4 you're seeing a lot of, because that's the container that we put things in that we want to send over the web. Windows has their own. Apple has their own. Everybody's probably heard the term MPEG before. There's lots of different versions of it. It was one of the first compression schemes that we had for storing things on DVDs and on Blu-rays. And there's a new one that I haven't seen much of yet, but it's called OGG. So these are containers. So when you think of a container, you take the raw or uncompressed video information, giant file. It's got a certain resolution, and it's got a certain frame rate. It's got audio. It's got pictures. That needs to be compressed into a smaller file, and that file needs to be put into a container so that different types of computers and operating systems can understand what it is. And there are open source, all of these things that we're talking about, there are open source, which are free to everybody, and then there are proprietary that somebody has spent a lot of time and money to develop, and so they want to get their money back, and they also use it to sell their equipment. So sometimes you have to pay for, or the equipment manufacturer that you buy from has to pay the company that made these, and that makes a couple of things. It makes things not as compatible. They can be more reliable, but you got to have specific software to make them work on both ends. And another consideration when you're thinking about how you're going to deliver to your users is you want it to be easy for them. You want it for them to be able to push a button and get your content. And if you pick a standard that requires a special plugin for their web browser, or it requires a special player that they've got to download, then it's a good chance that they're not going to go through that extra effort to get your content. So you got to think about compatibility with your users and how they're going to view what you're doing and how you're doing it. So that's another question to ask when you're looking at software and you're looking at hardware is, how can my users play this back as easily as possible? And one of the terms that you may have heard recently is that all web browsers, or recent web browsers, can handle now is HTML5 video. So it's a way of transporting and embedding video in web pages that you don't need any special additions to a web browser in order to be able to see and hear the audio and the video. So that's another important question to ask, is how am my users going to receive this? Do they have to do a plugin? Do they have to download a player? When we first started, that's how it worked. You had to have, think of when I was mentioning encoding and decoding the video, you've got to have something on each end that talks the same language. Same is true for playing video back on the web. So right now, it's very easy to play things like Facebook. Facebook, you got to have their app. YouTube will play on most video players, most web browsers, and there are apps specifically for those services. So when you're going to go to a system where you're grabbing the video, you're sending it somewhere, and usually there's a service that's going to help you send this to your users. What kinds of these files do they require from you? And what's the requirements of your user to see them? So after we talk about, we take our video, we take our content, and we squeeze it, we make it small, we put it into a container that our computer operating system can understand and play back, or if we've got a switcher, or we have a server that's going to send these files out. So we've got to make sure that all of those pieces are compatible with the hardware and the software at our end and the user end. And then we have to talk about how things get across the internet. I actually wanted to talk UDP first. So a couple of different protocols for moving stuff across the internet. And this isn't audio and video specific. This is just sending stuff back and forth. So, so protocol would be if you think about it as a language, okay? So you've got a person that wants to send information, a person who wants to receive the information, and if you do it in two different languages and they don't understand each other's language, then they're not going to be able to communicate. So they got to agree on how they're going to communicate. So these are a couple of different protocols that the internet uses for just moving information in general. And here's how they break down. So I'm going to start with TCP. TCP is interested in making sure that everything that you send makes it to the other end. And to give you an example of why that's important, let's say I'm going to send you a program that needs to run on your system. If I send that to you and there's something missing in the middle, then that program is going to run until it gets to that spot, and then it's going to stop, and it's not going to work. So if I don't get all of those pieces, then the stuff that I send is not going to be useful to me on the other end. So TCP, it's called a chatty protocol because the sender sends a lot of information about the data. We call it, one term for it is metadata, so describing the information that we're sending. And one way that this does this is it says, okay, I'm going to send you a piece. And then the other says, I got the piece. And then it says, did you get all of it? Here's a code that will tell you if you got it all. Checks. I got it all, send me the next piece. So besides the piece that you're trying to send, the information, let's say it's a word processing document or an email or whatever, besides the stuff that you got to send that you want to get to the other end, there's a lot of other stuff that's describing. So that's overhead, that's administration, that's red tape, that's, we deal with it in everyday life. All the stuff around the stuff that we're trying to do. So that is that particular protocol is, it has a lot of other stuff besides the data that you're trying to send. Another protocol for sharing information between computers on a network is called UDP. And this, how this works is it's not as chatty. It doesn't talk as much about the data. And if it loses a little bit of the data, it's okay with that. So we don't want to use that on things like sending a program file, for example. It does have a little bit of error correction, but not as much as TCP. And when we're using, and one of the reasons I'm describing this particular protocol is because in our video codecs, they are able to handle if we lose a little bit of data. It'll fill in the gaps. It will take information. Let's say we lost a little piece of one frame of video. It could take some information from the previous frame and the next frame, and it could fill it in for us. Kind of like if anybody as old as me remembers tape, and you had dropout compensators on tape. You know, tape got a hole in it. The software would fill in where the hole was. So that's, we can use both of these protocols for sending video back and forth, but they both have their ups and downs. So the protocols that I'm going to talk about next fall into those two camps. And again, the reason why this is important is because when you go to a manufacturer of, let's say you're going to have a piece of software on a computer that's going to help you move your internet across, whether you're going to shoot the parade and bring it back to your facility, or let's say you're going to grab a free service that's streaming to help you with content, bring content onto your network. Or if, let's say, you've got, you want to set up a regular stream when you do town halls a mile away from where you are, and you want to be able to bring stuff back without having to spend tens of thousands of dollars on a permanent link between those two places. Some examples. So when you're going to a manufacturer and you're saying, okay, I want a solution for doing this, how these two things fit into the picture is you know, how are we going to have the two computers talk to each other and share their information, and so that it gets to me on a timely basis. So one thing that's an issue with everything across the internet that you've heard, the term you've probably heard before, is called latency. It takes, because if you're in the 6 lanes of traffic, it may take longer for it to get to where it needs to go. And if the first frame of your town hall meeting and the 20th frame get there at different times and not at the right time, then you're going to have to wait a little while until you get the frames in between to put them all together to play them back. So that's a problem with anything across the internet, is how much time it takes to move that information. And if it doesn't all get there at the same time, you got to wait until you get all the pieces and put it together and then play back. You've probably seen that it's called buffering, where if the video pauses for a second before it continues, that's what it's doing. So what else did I want to show you guys? So we talked about containers. So here's some protocols that you'll hear about. So TCP/IP is sort of the foundation of how computers talk to each other on the internet. And then within that, there are families of protocols for moving information back and forth between them. Just different ways to skin in the same cat, basically. And there are also some that use, so the hypertext transfer protocol, HTTP, is what we use for moving web pages around. And so we have some protocols that use that, and the cool thing about using protocols within that family is that you don't have to, your web browser doesn't need anything special in order to be able to read them, because they're already set up to read hypertext transfer protocols. So if you do something within that protocol, then your web browser doesn't need anything special to see it or read it. Whereas TCP/IP, you've got a specific protocol that your hardware for sending your information and receiving your information has to have that protocol built into either its software or on a chip. Let's say you buy a box for encoding, then it's going to have that built into there. talk about the terms really quick. So real-time protocol is RTP, and then there is a family of protocols inside there. So real-time streaming protocol and real-time control protocol are ones that you're going to hear a lot, because that's some of the most popular ways of moving audio and video around. So when you're shopping for, again, software, hardware, servers, serving services, how do I put this? If they can handle more than one or two of these, then that's more value to you, because it's easier, different ways for your person to the more of these that are supported, then the different ways that your user can receive them. Okay, so what do I want to show you guys next? So here's just sort of a quick overview of how things get from here to there. So you're the publisher. You've got some sort of content that you want to send. And usually you could set up a computer specifically in your facility that you could send this information to and send it out to your users. But the requirements for that would be, if you get 5 users on your internet, that's receiving the streams, your computer's got enough horsepower to do that. But your internet connection might not. If it goes from 5 users to 150 users like that, the server, the computer that you have might be able to generate that many streams, but as you've probably seen when you're talking about bandwidth, is you get so much bandwidth for bringing stuff to you, downloading, and you get so much for sending stuff out, uploading. And usually you get a lot for bringing stuff in, but you don't get a lot for sending stuff out. So how you get around that is you send one stream, or maybe you'll send a couple copies of your stream in different sizes. So for example, if I'm going to watch it on my old phone, I might only want a low quality stream in order so I can see it. And if I'm watching it on my big screen TV at home, and I'm plugged into a wire that has a big download speed, then I can go with the 4K version. I can go with the big version. So you might send out 3 or 4 different copies at different qualities. But you're probably going to end up using somebody else in the middle to deliver that to your users. So that would be a streaming service. And the reason why you need to do that is that so they have lots of service, or if your user count goes from 5 to 5,000, they can scale that up using services like Amazon or Google or whoever they use to make multiple copies and satisfy as many users as you want. And they're willing to send you a big bill when that happens. So they'll charge you for how many people you've got watching. So from the streaming server, then it goes to the viewer, and then the other thing you got to be worried about is, okay, what's the viewer got on their device that they can receive? You got to be able to make whatever it is they've got, and we have years worth of devices, and they're not all going to be able to do the latest greatest thing, which is H.265, is what you see now and coming up next. An old iPhone 1 is not going to be able to read that. So you've got to pick the different protocols that your users are going to be able to see, and so it's complicated. But there are services that will do this turnkey for you and help you figure it out, and people like me and the folks that you're going to see here today that will help you navigate it and try to pick out what's best for you. When I'm having this discussion with people, I start with, what are you trying to do? Who are you trying to serve? Let's work back from there. So what you're trying to accomplish before the technology, figure that out first, and then there'll be lots of different ways to do it, and no wrong way. I think that's it.
We should do some just Q&A.
Yeah.
Engage a little bit.
Yeah, yeah.
I was wondering what you use when you go into a situation to see what sort of bandwidth is available.
Sure. We talked about this earlier. So Just a real quick thing that's on the internet. You guys have probably used something similar, but I'll show you what I've been using. So there's a free service online that's called Speed of Me. So I just go into a facility. I know I got to use the internet for transmission or broadcast or something. I just want to see, okay, what kind of service have I got here really quickly? It's free, and it doesn't need any plugins. It uses HTML5. There are lots of these out here. If you do a Google search for speed test, there's lots of them. But the cool thing about this one is it will work on mobile devices really well. It doesn't need anything special. So, and it has advertising for it. That's how they pay for it. So I load it, I hit start, and the first thing it will do is it will download a series of packets of information from a server. And what it will do is it will do different sizes. So it will start with a small piece and then a little bit bigger piece and a little bit bigger and a little bit bigger. When you do this on your desktop, it will actually show you a graph. And so what it does is if you watch I usually do this like 3 or 4 times to get sort of an average. And normally I have to report this to my client because they've paid for a certain amount and we want to make sure they get what they pay for. Same for you at home. Do this at home, and if you're not getting what you're paying for, then you should be complaining because you've paid for a certain size pipe, and if you're not getting that size pipe, you should complain. So just a really quick, on this particular connection, so I'm on a Wi-Fi connection, so I'm getting 28 megabits down and 8 up, and like I said, I'd run it a few times just to. So for example, if we go back to that scenario where we're going to do something in the public square, maybe we're going to we're going to get the Wi-Fi from the library. You go over to the library, log on, say, okay, what do I have? What does my box need? So the streaming equipment that I use for broadcast is anywhere from 50 to 60 megabits per second down to as low as 10. And to give you an example of how do I gauge what that is, if you've ever had DSL from like the phone company, that's in the 10 megabit range. Right at home right now, I think for $70 a month, I get 100 megabits at home, and I don't have fiber. That's still copper. So if you have one of the fiber services, you could have hundreds of megabits per second. So so that's just sort of a gauge of. So that's a quick free thing. You go to the site where you're going to use something, whether it's wired or wireless, or even over, let's say you're going to use a hotspot. You can check on your hotspot. I think I checked my phone this morning just to tell you. So I have 2 phones. I have a Verizon and an AT&T for backup, and I did it this morning, and I think I got roughly about 30 down and 10 up, just on a regular phone device.
But it's the up that we're most concerned with. If you're testing from a source that
Right.
you're going to push
Right.
to another location,
Right.
you want to see what that bandwidth is.
So normally you're concerned with how fast do I get the stuff that I want off the internet. So most people aren't trying to stream video. So we're worried about how much can I push out. And sometimes you're going to have to arrange for it to have more than usual in order to stream. To give you an example, if you're going to, let's say you're going to stream this parade and you want to send out 3 different streams, a small, a medium, and a large, depending on what the person's going to receive. Let's say, if you go to a YouTube video clip, you get to choose, what resolution you want to pick, depending on what kind of speed you have. So if you're just going to send one stream, you might only need 10 or 20 megabits. But if you're going to send 3 or 4 streams, you're going to need to have more than that. So that means that you're going to have to either pay for a service, or you're going to have to be in touch with the IT people for them to give you what you need to get out. Just another quick thing that I didn't cover that I just wanted to say really quickly is when you're using somebody else's internet, the thing that you have to be worried about is that there's a device that's sort of a cop that watches what's going on called a firewall. You've probably heard of it before. On that firewall, they may or may not allow streaming. So if they don't, normally, then you're going to have, for your particular connection, you're going to have that turned on. Also, a thing that happens is there are devices in the firewall or your router, they're called ports. And if you think of them as doors in your house. So the more doors in the house that you have, more windows, the more ways to get things in and out. And so a particular manufacturing of equipment or software might require a particular window or door to be open that's normally closed by the IT department with their firewall. So it's another thing that you have to consider when you're going to try to do this with somebody else's internet is the port and the speed that I need going to be available to me on that local network. Did you think of anything else, Randy, that we talked about? I forgot.
Other questions? Could you expand upon the idea of node saturation?
So here's a good one. Let's say you've got a device like Comrex over here. You got a camera on your shoulder, and you're going to be using a cell service for shooting in the crowd in a stand. You go out the day before, it works great, and then you come and there's 20,000 people there using the same cell service. There's so many people that are using the same thing as you. We're stuck in the 6-lane highway and we're not going anywhere. So that's a problem with trying to use different services. And one of the ways around that is use multiple services, multiple hotspots, if you will, multiple providers, so that a little piece of your stuff goes on everybody's individual network, and then it has to be all joined back together again. And you might have to wait a while for all those pieces to come back, and we hear latency again because it's going to take a little while for take those pieces apart, send it in different routes, and then bring it all back together at the end. So node saturation. So if we call a spot where people access a network, whether it be a cell tower or whether it be a router in your studio, if you have too many people trying to access that same spot at the same time, you're in 6 lanes of traffic and moving nowhere. So that's node saturation. So node would be an access point, and saturation would mean it can handle so much bandwidth. Again, we're talking about bandwidth like we talk about how much internet we're getting up and down. That device is also a potential bottleneck as to how many connections it can handle at once and how much data it can move at once. Usually, the connection is the bottleneck, not the equipment, local equipment, because usually it can run faster than whatever network speed that you have. But sometimes, if you got so many people on it, that can be a problem.